Hello guys, welcome back to my channel. I do lead code problems, tech related stuff, and problem solvings in general, okay? So today we're gonna do another lead code problem called +1, problem number 66. It's an easy problem. We're giving a large integer represented as integer array digits. We're giving integer array digits. The digits are ordered from most significant to left to right. Does not contain any leading zeros. By 1 and return the increment the large integer by 1 and return the resulting array of digits. So let's say it's 1 2 3. We increase the last element by 1 and then we return it 1 2 4, right? That's it. And then when you see 4 3 2 1, we increase the last element, we return, right? 4 3 2 2. In the case of 9 becomes 10. We increase it one place, it becomes 10. Okay, so that's all pretty much, uh quite not hard, but I like doing easy problems. I love easy problems, that's why. Okay, let's start by int length equals digits dot length. Okay, and then we're gonna use a method. We're gonna use a carry. Okay, let's say in this case, like the one you see right here, 9, and if it exceed 9, if we add 1, becomes 10, right? So we need to carry 1 to the other side. Otherwise, normally we can just return, we will just return 0 if 8 plus 1 like this. Like in this case, 4 3 2 1, we just increase and it doesn't go over it, so we can just return it. But if it goes over, we need something to carry it, okay? So we do carry equals 1. Why do we set two ones? Because we need to add 1 here, right? We need to add 1. So we just add the carry. We set the carry to 1. So 4 and I equals, we're gonna reverse the for loop. We're gonna come from the back. I equals length minus 1. We're doing length minus 1 because we're working with index space, okay? I is greater than equal to 0. In the worst case, if it goes until 0, it should be able to go until 0. I minus minus. And then in sum equals to digits at I, which is the last digit, the array, plus carry. We're supposed to add 1, right? We're supposed to add 1. We're gonna change the digit, okay? We're gonna digit at I. We're gonna change the last element of the array. We're gonna do sum mod 10. So sum mod 10 will give us the last element if there are two elements. But if there's only one element, it will give us that current element, okay? So if it's 10 mod 3, will give us 3. But if it's two element, it will give us the right side of the element, okay? And then we have a carry. Carry equals sum divided by 10. So in this case, carry is already 1, right? Because we added here, carry is always gonna be 1. But in this case, let's say sum is less than 10. The result, the sum or the divided result will be 0. Okay, if 9 divided by 10, it's gonna be 0. Okay, so it's gonna be 0. So we check if carry equals 0. That means we don't have to carry anything, okay, to the next, so that we can just return it right there on the spot. Digits. Otherwise, that means it has been carried, right? So what we do, but what about this case? 999. So 2 here. No. So 1 will be here, then it's gonna be 0 here, it's gonna be 0 here, and then it's gonna be 0 here again after adding them. And then there'll be 1 extra. So we need to increase the size of the array. So we may assume that all the elements here are 0 and the first element, it's only gonna be 1, right? So int arr equals new int of size length plus 1. And then we're gonna do arr at 0, which is the first element, equals 1. And then the rest of the elements in the array are by default 0 if we don't clarify anything. So it's gonna be 1 0 0 0 until length plus 1 size, okay? return array. Let's run the code. Oh yeah, it works. So you can see here 999 becomes 100, 1000 basically, right? So you can see why, what's the point of doing this, right? You will see, because this will give us the last digit if it exceeds 10, and this will give us the, we check if we need to carry the sum or not. If it's 0, that means we're done with we just have to add the last digit. We don't need to carry it along. That's all, guys. Thank you very much. And if you need any, let's submit the code. See, 0 millisecond beats 100%. Fastest algorithm in the world. So guys, thank you very much, and subscribe for more. Happy coding.